I'm here with Derek, and this is an actual episode of Quarantine Science Lab. And today, Derek is going to use some dangerous chemicals, specifically sodium hydroxide and, what's that say, Derek?
Hydrochloric acid.
Hydrochloric acid, 12 molar. I've watered it down a little bit, so it's more like 10 or 8 molar, but it's pretty strong. I've watered it down just to the point where there's no noxious fumes coming off it. And now what's going to happen is Derek is going to make from those two dangerous chemicals they're food grade, by the way, both of them. Derek's going to make something that I'm going to eat. So my survival is in Derek's hands. Are you going to kill me, or are you going to be careful and probably be careful, or probably poison me? Anyway, when we're done, we're expecting that Derek is going to produce a vial of sodium chloride like this from the sodium hydroxide and hydrochloric acid over here. Okay? Ready to get started?
Yeah.
All right. This is great. So first off, see what's happening there? So do you see that the drop of sodium hydroxide you put there made the litmus paper turn a really, really dark purple, blue, almost black. And on the other end, the hydrochloric acid made it turn bright red, right? Like blood red, right? So that means that this one, the hydrochloric acid, is extremely acidic, has a very low pH, and the other one, the sodium hydroxide, has a very high pH. They're each about, on the scale here, right? The acid is about a pH of about, what, 1, right? And the sodium hydroxide is what, like an 11, right? 11. What do you think? Is that 11? So what we're going to start out doing is I'm going to pour almost all of the sodium hydroxide solution into this tray. This is going to be our mixing dish. I'm only going to reserve a little bit of it to make adjustments later on, okay? Then I'm going to take this hydrochloric acid solution and I'm going to pour this. What do you think is going to happen? Do you think it's going to foam up? Do you think it's going to explode? Or do you think it's just going to sit there?
Sit there?
You're right, actually. It's not going to release gas. It's not going to combust. It's just going to heat up. We may see some vapor coming off, but that vapor is just going to be water vapor. All right, now I'm going to leave a little bit of the acid solution here, okay? So that we can make adjustments later on. Now, let's take a measurement. Let's take a measurement of the pH. I think this is 1 sheet, but it feels like 2. Anyway. All right, here. I don't want to put the litmus paper in there, so I want you to, over the tray, keep it over the tray, take up a tiny bit, and put just, okay, you have a ton in there, okay. Now just put one little drop on here. It's still what? What color is that?
Like the 11 dark.
Yeah, it's still extremely alkaline, okay? So what do we need to add to it to try and neutralize it?
I don't know.
The acid.
Wait.
It's extremely alkaline, or it's very alkaline. So we need to add some of the acid.
Hey,
Yeah.
It's going around.
Yeah, I know, it's absorbing into the paper. Let's put a substantial dosage of the acid in here. And if necessary, I'll go get some more. Please mix that around very calmly. Mix it around, mix it around. In the prior experiments when I was practicing, you know, I didn't realize like just a couple drops would turn over this solution and take it from acid to alkaline. And I kind of had a difficult time balancing it. We're almost done here. So what's going to happen when we hit that target pH? Do you know what that tells us?
No.
That tells us that our solution is perfectly neutral, like water.
But you can drink it?
Well, what would happen if I drank it?
Your insides would burn.
Why would they burn if it's perfectly neutral?
Yeah.
The reason I wouldn't drink it, but I would taste it, is because what's in there? What's the product that we're looking for? Sodium chloride.
Oh, yeah.
Therefore,
that's salt.
salt, yes. So what would happen if I tasted it? What would it taste like?
Salty.
Salty. I think I want one more drop, 2 drops, 3 drops, because I want to really bring this over to a 7. Give me one drop of that. One big drop in the middle. Don't squirt it, just a drop. Give me another one. That's it. Put it back. Good job. You just handled a dangerous chemical.
Yay.
I think we're neutral, bud. I think we're perfectly neutral. Let's get out a brand new sheet and test it, and we can show people. All right, come on, give me a drop here.
Okay.
Don't spill it off the paper. There we go. What do you think of that? Do you remember what the 7 is supposed to look like?
That doesn't look like a color at all.
Well,
it looks like a little bit like a 7.
yeah, like a 7.
Mm-hmm.
So do you think it's neutral? Do you think I could taste it?
I don't know. I don't really recommend it.
You don't recommend it? Why? These are food grade chemicals, bud. I bought from reputable sources. You don't think I should taste it? Well, how are we gonna know if our experiment was successful?
Let's not know.
Let's not know. Well,
Let's
we have to know.
Let's hope, not know.
All right. So, come here, bud.
I'm not.
We need to have a serious conversation. So normally on Quarantine Science Lab, we would never ever combine chemicals from an experiment and put them in our mouths. We would never ever do that, except that today I have food grade chemicals. Hey, careful. I have food grade chemicals that we started with. And we have been careful. We use distilled water to combine those chemicals. So we haven't introduced any foreign or unsecured elements. So now I think this is for me to taste right now.
Oh, you knock yourself out.
Knock myself out?
Actually,
I might do that, right?
I mean, you're probably going to poison yourself later.
You think I'm going to poison? Now I'm going to use our food grade.
Poison yourself out.
We're going to use a kitchen implement, not a laboratory implement. Come here, bud.
No.
And I'm going to taste it. Come here, bud.
Ew.
This is a kitchen now. I haven't used any laboratory element here, like a lab spoon or a spatula that's been contaminated. I'm using a clean kitchen grade. What do you think's going to happen if I taste it? Come here.
You'll drop dead.
You think I would drop dead?
Probably.
Come here. Come here. You ready? Are you going to taste it next?
No,
Come here.
I'm not going to taste it at all. Why
Come
don't
here.
you? Did you just swallow it? Okay, yeah. He's dead. Yeah, nothing to see. No, nothing to see. No, nothing to see. Just let him die. Just let him. Just let him die. Just stop. Don't.
You know what we have?
Throw up on
Come on, look out. Get out.
We
Get
have-
off of there.
We have
Come here.
throw up on the floor.
No, we don't have throw up on the floor. I didn't drool on the floor. No, we have salt water.
Okay, cool. And I'm gonna.
That is
I'm
some
not sure.
salty water.
Okay.
I would say it's saltier than tears.
Do you taste the tears?
Everybody knows what tears
So
taste like.
did I.
Come here. No, everybody knows what tears taste like. But it's not quite as salty as the ocean. I'm a little bit disappointed in the salt level. I thought it would be more. That's why I used some really concentrated solutions. And adding more of each of them not going to make it more salty. So, but it's about the same as seawater.
Okay.
Let's have a debriefing. Come here. So, Baba, come on, bud.
No.
So, we mixed a strong sodium hydroxide solution with a strong hydrochloric acid solution. So what elements are we combining? We have hydrochloric acid is hydrogen and chlorine ions, and the sodium hydroxide is sodium, oxygen, and hydrogen. So that's 4 elements, and we're breaking apart some bonds when we mix them. The reaction breaks apart some bonds, and it creates some new bonds. And the new bonds it creates is the sodium, which is very reactive, with the chlorine, which is very reactive. And we are breaking some bonds and creating some other bonds. So breaking bonds absorbs energy, and creating molecular bonds releases energy in the form of heat.
Yep.
Okay, so
Yep.
if the net result is, what did we observe the temperature do when we mixed them? Did it go up or did it go down?
Up.
It went up, right? So it released energy toward our thermometer and toward us, our fingers. I could feel it get warm. It was releasing energy. That's exothermic. The net result was exothermic, so we were creating more bonds than we broke, right? Mm-hmm. And that's why it was exothermic. The net result was a release of energy, right?
Yeah.
Now, to get the salt crystals for us to eat out of this water solution, because that's what it is, it's water.
We must filter it.
No, how can we filter it? Do you see any, come here. Tell them what we need to do.
Evaporate it.
Come here. Tell people what we need to do.
Evaporate it.
We need to evaporate it. Evaporate it.
Oh, I actually made you. Oh.
Yes. We need to evaporate it. And you know what's really convenient? Right behind us? We have an oven right behind us where we can put that in there and we can actually set the temperature. What do you think would be a good temperature to set the oven at?
100
100 centigrade?
centigrade.
Wow. Why would we put it at that temperature?
Because it is equal to 200 something.
12.
212.
And what does that temperature do? What happens at that temperature?
It evaporates.
It doesn't just evaporate. The water changes state.
Gas.
Exactly. And what do we call that gas?
Gas.
Steam.
No.
Or water vapor. What temperature should we put the oven at?
100 centigrade.
Wait, but we don't have centigrade here. We only have Fahrenheit.
212.
212? How about I put it to start with at 250? Okay, so let's put this in the oven. So when we tuned out last, we had put the liquid water and sodium chloride solution in the oven in this tray. And after a couple different temperatures and going out to eat and then coming back, it had crusted over, which is what we wanted. We got a pretty good. I did the heavy scraping because it would be painful and hard for my son to do. But this is our yield that we got from our experiment. This is the yield. You can see the yield that we got. That's all sodium chloride. So what's this tool called you're using?
A mortar.
A mortar and a pestle. So this is a tool that's literally thousands of years old. And this is our kitchen one that's used for food because we are in a food grade context. We used all food grade. Oh, here's a piece of our salt. You want to taste it?
No.
I taste it. It's delicious.
Wait, you go to this side.
All right, that's great. Good thinking. Oh, it's all right. Go ahead. Good thinking, Baba. You're smart. There you go. While you're scraping up another teaspoon, I'll dump that in. Oh, we got quite a yield here, bud. We're filling up this bottle. You know what that is?
What?
Salt.
Cool.
That is salt. It doesn't have a really powerful flavor though. All right, so this is Baba's bottle of sodium chloride, food grade. All right, thanks for tuning in to Quarantine Science Lab. Have a good night. If you want, we can put more, but I would like you to tell the people what it tastes like.
No.
Come on, bud.
No.
All you have to do is lick your finger and put it there.
No.
It's yeah. What did you just do?
Nothing.
Did you taste it?
No.
I'm gonna see the video later on.
Well, I didn't taste it.
What did you do? Lick the camera?
No.
Food safe, bud. Come on.
No.
All right. You want me to do it?
Yeah.
Come on, Derek. Just a little bit. Come on.
No. I'm not doing it. And you can't force me to do that.
No, you're right. I can't force you.
Ha.
Come here, Bubba. Don't make me beat you. Come here.
You also have a nuclear bomb in your shed.
No, we don't.
Aw.
We don't have a shed. Out of here, dog. Hi, puppy. Oh, Lollipop wants to be on camera. Come here. Come here, puppy. Oh, look at the puppy. Oh, the puppy. Now, when she gets a love overdose, she starts to growl. Oh, that's a good girl. Mwah. Fun doing this?
Yes. Yes, I'm trying to fake a smile.
Oh my God. All right.
I'm trying to make it.
You know what? Go brush your teeth and go to bed.
No, wait.
Yes.
Wait. No,
So-
we call the gas.
Yeah, don't fart. No,
You're the
no
gassy
farting
one.
on camera.
You're
Hey,
the gassy one.
don't be pointing fingers. Mick Jagger, pointing my finger. I'm pointing my finger at you.
I'm pointing
All
my
right.
toes at you.
What?